Hello friends, welcome to MOL-MENTUM. Let us solve this year's question paper of chemistry which was held on 28th of Feb. Okay, so yes, this is not an official of course, so it may be having some errors. Okay, let us solve first question. The very first one is consider the following. So in this we have to find delta G. We know the expression of delta G is equals to minus NFE naught of the cell. So in this case, N value is 2. So this will be minus 2. F is given 96500. And when you calculate E naught, so 0.80 plus this one. So it will be 1.54. So this will come out to be minus 301080 joules. So when it converts to kilojoule, it becomes this is the correct option. This one is the straightforward question. So for a complex reaction, molecularity has no meaning. In this case, again, very simple question. So the question is about order of reaction. So basically, from the rate law expression, you just have to add these powers. So order of reaction is 1.5. This question again from class 11, basic electronic configuration. This is the correct option because of exchange energy concept. Exchange energy means half filled and fully filled orbitals are more stable than partially filled. So this one is half filled. This is also exactly half filled. In this case, the correct option is going to be this because platinum is in plus 2. Ammonia contributes 0 and this is minus 2. X minus 2 is 0, so X will be plus 2. So plus 2, these two options are there. But dichlorido comes after amine because A comes first, C comes later on. This is the correct option, option B. Okay, so this question is about heteroleptic complexes. So heteroleptic complex means any complex in which at least two different types of ligands are present. This is the only example where at least two different types of ligands are present. Other only one ligand are only one type of ligands are present. In this case, we have to find the chiral compound. So chiral basically means the carbon which is having all four different valencies. So butane 2-ol, when we write butane 2-ol, it becomes like this. So on one side we have CS3, on another side we have OH, then H. On this side we have ethyl group. So basically this carbon is having all four different valencies. So butane 2-ol is going to be the correct option. In this case, again, what you have to remember is branching is inversely proportional to boiling point. So as branching increases, boiling point decreases. So that means normal structures are going to have the highest boiling point. So pentane, of course, 1-ol and butane 1-ol. So OH group is present on first carbon. So these two are going to have the highest boiling point. So option C is correct. This will identify compound ethane nitrile. Okay, so this is simple reduction. So the product is going to be ethyl amine. Option A. In this case, a very simple, straightforward question. Thymine is the base, which is present in DNA but not in RNA. Peptide bond, very simple. Amino acids are joined together by peptide bonds. So NHCO, CO, and then CONH2 is called peptide bond. In this case, again, question number 12, option D is correct because this is a case of mutarotation. Mutarotation. Mutarotation means rotation in a specific degree, means change in a specific degree of rotation. So this is exhibited by uh, alpha beta types, means alpha two types of anomers. In this one again, question number 13, molecular is 2 assertion is correct, reason is correct, so option A is correct. Both of them are correct. Zinc, cadmium, mercury, they are not considered. Yes, it is correct. So assertion is correct. Fully filled, correct. So again, both of them are correct. Option A. Question number 15, aromatic primary amines can be prepared by Gabriel thalamide. So the option is can be prepared by Gabriel thalamide. Yes. So again, option A is assertion is correct. Aryl halides do not undergo this one. So I do not undergo. Yes, this is also correct. So option A is correct. In the question number 16, assessor glucose gets oxidized. This is correct. Carbonyl group is absent. No, this is incorrect. So in this case, option C is correct. This was all about MCQs. Now coming to the question, section B, descriptive part. So in this case, we have a first order reaction. So in which concentration decreases from 0.6 to 0.2. So let us quickly write the rate law expression. So K is equals to 2.303 by time given is 5 minutes. So I will write it log initial concentration is 0.6 and it decreases to 0.2. So it becomes K is equals to 2.303 by 5. So log 0.6, 2 3s are 6. So this will become log 3 and log 3 is equals to 0.48. It is given in the question. Okay, so I will directly multiply it by 0.48. So when I multiply it by 0.48, the answer is 1.1054 by 5. So it will be equal to roughly around 0.221 and the unit of rate constant is going to be minute inverse because this time is in minute. So this is the correct option, correct answer. The second or part of this question was rate constant K is given and we have to calculate time required for the three-fourth of the reactant to decompose. So when three-fourth reactant is consumed, this you have to understand. Three-fourth consumed means what? 1/4 is left. Okay. So let us again write the equation, first order equation. So I will write T is equals to 2.303 by K is given. This is the value of K. So 2.54 into 10 to the power minus 3 log. Now initial concentration, let us assume it to be A naught or R naught, whatever you want. So if three-fourth is consumed, that means whatever is left is 1/4. So this is the initial one. So remaining concentration is going to be 1/4 of the initial. That means A naught by 4. So A naught will cancel out each other. So I can write it directly as T is equals to 2.303 by 2.54 into 10 to the power minus 3 and this will be log 4 and log 4 can be written as log 2 square. So when I solve this one, I get T is equals to basically now again I will write log 4 is given. So I will put the value of log 4 directly instead of writing it like this. So it is log 4. So log 4 is equals to 0.60. So I will directly multiply this. So I get the value 1.3818 divided by 2.54 into 10 to the power minus 3. So this becomes equals to, when we solve this one, it comes out to be 544.02 seconds. So this is the correct answer. Time is going to be 544.02 seconds. Next question. What is activation energy? A very simple question. Activation energy is the minimum amount of wait. I'm really sorry. Minimum amount of energy required to cross activation energy barrier, or I can write it as threshold barrier. That's it. That means we get a curve something like this. So this is the value and this is the energy of the reactant. So basically this height is called activation energy and this is represented as EA. Second part, write the unit of rate constant for zero order reaction and second order reaction. So one thing, that general representation that we have for rate constant is mole by liter 1 minus n and second inverse. So for zero order reaction, n is going to be 0. So when n is 0, so 1 minus 0 becomes 0. So basically, what we get is, for zero order reaction, it is mole per liter per second per second. For second order reaction, when n is 2, so when you write n is equals to 2, so 1 minus 2 becomes minus 1. So basically, mole becomes minus 1, liter becomes plus 1. So the unit is going to be mole becomes minus 1, liter becomes plus 1, and then we have second inverse. So this is the unit for second order reaction. Okay. Then again, next question. First IE of chromium is lower than that of zinc. So as we all know that chromium outer electronic configuration is 4s1 and 3d5, whereas zinc is 3d10, 4s2. So of course, removing an electron from this one becomes easier. Second thing is, when we remove one electron from this one, chromium gets a stable electronic configuration 3d5, that is exactly half filled. Whereas when we remove one electron from this one, it becomes 3d10 and 4s1. So which becomes slightly less stable in comparison to this 3d5. That is why first IE of chromium is lower than that of zinc, because it is easier to remove electron from 4s1, which leads to the formation of 3d5, which is more stable. Okay, second part, mention any one property of the transition element which makes them good catalyst. So there are various properties, but since it is about catalyst, so role of catalyst is to provide the surface area for the reaction to happen. That means to provide the area for the reactants to react. Surface area is very large. Second thing, they have variable oxidation states. That means they can go from +1, +2, +3, +4. Even in case of manganese, it goes from +2 to +7. Variable oxidation state. So these are the two most suitable region for the uh, transition elements to be a good catalyst. Next one, define coordination number. So coordination number is basically number of ligands. I'm writing for first one. Coordination number is number of ligands, donor atoms, ligand, donor atoms join together or directly to the central metal. This represents quantum, coordination number. Second question, second part, this one COEN3 and Cl3. So this is a case of MAA3 type complex. These type of complex exhibit optical or enantioisomerism. Enantioisomerism. So if I write the structure of this one, so I will write in a shortcut way. So this is cobalt, and this we have, this is the mirror. So basically En means ethylene diamine. So I'm writing it directly as NN, NN, and on this side also N, N. So when we take the mirror image of this one, so basically what we have is NN, again N, N, and this side also NN. So basically these two are mirror images which are non-superimposable. So they are enantiomers. Enantiomers. These are called enantiomers. So they exhibit this type of isomerism. Draw the structure of the given compound 4-bromo 3-methyl pent 2-ene. So the first thing to write is pent 1, 2, 3, 4, 5. Now since it is written that 4-bromo 3-methyl. So 1, 2, 3, 4. 4-bromo and 1, 2, 3 methyl. So I will write methyl and it is written 2-ene. So 1, 2. This is ene. Now fill all the valencies with hydrogen. So this will be CS3 and this will be CH. 2 plus 2, 4. This we have H and this is again CS3. This is the structure of the given compound, part A. Now, what about part B? What happens when chloroethane is treated with aqueous potassium hydroxide? Keyword is aqueous. If it is alcoholic, then it causes elimination. But since it is aqueous, so aqueous KOH causes substitution. Alcoholic causes elimination. Since it causes substitution, so it will directly sorry, it will directly substitute the compound. So the we have chloroethane. So this is CS3, CS2, chloroethane, and since it is aqueous KOH, so directly this OH will replace the Cl, and we will get CS3, CS2OH plus KCl. This is the product. This type of reaction is called nucleophilic substitution reaction. Okay, next. Then question number 22, we have 1.1 gram of this one. Okay, so in this question, what information we have is the boiling point of benzene got raised from 35323 to 35393. That means we can write the value of delta TB. Elevation, what is the elevation? So this is 93 to 23. So this is basically 0.7 Kelvin. This is the value of delta TB. Okay, so we know the formula. Formula is MB is equals to KB into WB into 1000 divided by delta TB into WA. So directly put all these values. We have KB. KB is given. This is KB 2.52. WB we already know it is given 1.5 gram. So WB is 1.5 then multiplied by 1000 divided by delta TB. We just determined it. It is 0.7. WA. So this is given 90 gram. So this is 90. So basically when we solve this one, so the value that we get is 3780. 3780 by 63. So MB is going to be 60 gram per mole. So this is the answer. And this is also the molar mass of the benzene. So basically that's what we have to determine, the molar mass of the solute. So molar mass of the solute is 60, which is nothing but the molar mass of the fine. Then question number 23. So here we have a tin and hydrogen electrode. Okay. So since we know that hydrogen is a reference electrode, so EMF is given 0.4. So first let us calculate E naught cell. So for hydrogen it is 0 minus this value is minus 0.4. So either we can write minus 0.14 or directly we can write it as plus. So E cell is going to be plus 0.14 volt. Now, while solving these miss any question from Nernst equation, the thing is we should write the oxidation and reduction reactions. So since hydrogen is having better reducing tendency, so it is going to be the cathode and this will be the anode. So for oxidation we have 10. So 10 changes from Sn to Sn2 plus, it will release 2 electrons. At reduction we have 2H plus, it will accept 2 electron and will get converted to H2. So the value of N, number of electron, is going to be okay. Then directly put these values. Okay, fine. If you, we can also write overall reaction. So overall reaction is going to be Sn plus 2H plus, and this will be Sn2 plus plus H2. So here concentration is very important. So for Sn2 plus we have 0.001. So I will write it here 0.001, and for H plus we have 0.01. So I will write it 0.01. Since it is solid, so its concentration is going to be constant or unity, and this also is going to be constant because hydrogen pressure is given 1 bar. So it is constant, and this is solid metal, so it is again constant. So let us quickly solve it. So when we apply Nernst equation, so E cell becomes E naught cell minus 0.0592 or 592 by n log product upon reactant. So we can write it as, we can directly put these values in the, as it is given in the question. So I will write it directly. E naught we have already calculated. So this will be 0.14 minus 0.059 by 2, n value is 2, log, and on product side we have this one 0.001. So 0.001 can be written as 10 to the power minus 3. On reactant side we have 0.1, so 0.1 is written as 10 to the power minus 2, but since 2 is written, so we have to raise it to the power of 2. So basically what I can write is 0.14 minus 0.059 by 2 log. On the above side we have 10 to the power minus 3. On the below it will be 10 to the power minus 2 square. So it will be 10 to the power minus 4. On the above side we have 10 to the power minus 3. Below we have 10 to the power minus 4. So when it goes upward, so it will be log 10 directly. I can write it 10 to the power minus 3, and this will be 10 to the power minus 4. So this will be 0.14 minus 0.059 by 2. This will be log 10. Log 10 is nothing but 1. So when we solve this question, we get E cell is equals to 0.11 volt, and this is the correct option. 0.11 volt. Question number 24. Straightforward question. NCRT. So when KMnO4 is heated at this much temperature, so what we get is K2MnO4 plus MnO2. This is pyrolusite. This is used for the preparation of potassium permanganate, and then O2. In the second one, Na2Cr2O7, it is a reaction for the formation of K2Cr2O7. So we get K2Cr2O7 plus 2 moles of NaC. This is the simple reaction. Now, this question, why it is difficult to separate lanthanide elements in pure state? There are various reasons. The very first one is very similar atomic size. Atomic size, and this similarity in atomic size is due to lanthanide contraction. That's it. So that is why it becomes very difficult to separate them. Next question. CONH3 is diamagnetic whereas COF3 is paramagnetic. Okay. So NH3 is a strong ligand. NH3 is strong. NH3 is strong. It causes a pairing of inner electron. Pairing of d electrons. And when this pairing occurs, that means because NH3 is a strong ligand, so it has large CFSE value, large CFSE, crystal field stabilization energy. What does it mean? That means del O is much larger than pairing energy. So electrons prefer to get paired. Electrons are paired, and when electrons are paired, it becomes diamagnetic. So we can write electrons are paired. That means it is low spin or diamagnetic. In case of F6, fluorine is a weak ligand. Weak ligand. D electrons are not paired. Since it is weak, in this case, del O is smaller than P. That means the energy gap between T2G and EG is smaller. So electrons get promoted to the higher energy level, that is T2G. So electrons are unpaired, and when electrons are unpaired, we get high spin. High spin, that means paramagnetic. So basically in this case, I think we have four unpaired electrons. So when we use the spin only formula, we get, I think somewhere we get 4.89 or 4.87 maybe Bohr magneton. This is the value of magnetic moment for this complex COF6. COF6. Again, we have similar question. Write the electronic configuration for D4 if del O is greater than P. So when del O is greater than P, so basically we have two sets like this. This one is called EG and this one is called T2G and crystal field. So D4, wait, this is incorrect. In we have EG and T2G like this. T2G in ground state and EG higher energy level. EG means these are the orbitals of dx square y square and dz square, whereas these one are dxy, dyz, dzx. So when it is D4, and that too when del O is greater than pairing energy. So when del O is higher, that means this gap is wider. So when this gap is wider, electron will prefer to get paired. And since we have to D4, so 1, 2, 3. So when del O is higher, that means electrons will not go to the EG level, rather they will get paired up. So for this case especially, when del O is greater than P, we have the configuration. This is T2G4 and EG0 because gap is wider. Del O is higher. All right. Next question. We have to write the major product in this reaction. Fine. This reaction is again a very good example because in this case double bond remains intact. Why? Because the intermediate which is formed between reactant and in between reactant and product is stabilized by pi system. So basically I will directly write the product without going into the detail of this reaction. This remain as such because this is stabilized by pi bond. So this is the product, 3 bromo cyclohexene. Okay, what is a racemic mixture? A racemic mixture means whenever we have two means equimolar composition. So basically I can write equimolar. Equimolar means equal mole, 50-50%. Equimolar mixture of any enantiomer, any enantiomer, like if I take an example, so plus minus lactic acid or glyceraldehyde, any example, lactic acid. So whenever we have 50-50% of plus and 50% of minus, so basically it becomes a racemic mixture. Okay. Then parachlorobenzene has higher melting point as compared to its ortho and meta isomer. This is a very simple question because para is symmetrical. Para is symmetrical. If I make the structure, this is called para, means 1,4 is para. So whenever para dichloro, so 1,4 is called para. Para because of symmetry, that is the first thing, and because of this symmetry, it leads to more close packing. Earlier there was a chapter of solid state. Close packing means the space between the two uh, molecules of these compound is very very less. So they are highly packed, densely packed, and when they are densely packed, that means they have high van der Waal forces of attraction. So which makes them basically have higher melting point in comparison to ortho and meta because they do not have that much close packing. Okay, in question number 26, okay, so these are the name reactions. Rosenband. Rosenband, as we know, COCl, acid chloride. When it reacts, it is a means reduction of acid chlorides. Palladium in BaSO4, this is called Lindlar catalyst. So when it reacts with this one, we get benzaldehyde as a product along with C as a byproduct. Canizaro, it is a reaction in which no alpha hydrogen is present. So either benzaldehyde or formaldehyde. So when we have 2 moles of formaldehyde and it reacts with any base, it is basically a self-oxidation reduction reaction in which one molecule is getting oxidized, another one is getting reduced. So aldehyde upon reduction gives alcohol. So one aldehyde molecule will get reduced to alcohol, another one will get oxidized to its carboxylic acid salt. So this is the Cannizzaro reaction. Then Hell-Vollard-Zielinski HVZ. HVZ is basically alpha halogenation. Alpha halogenation reaction. So when we have to increase the acidic strength of any carboxylic acid, this reaction is used. If I write RCOOH plus Br2, or you can take any other halogen. This reaction occurs in presence of phosphorus. So what we get is at alpha position, this is the carboxylic acid carbon. This carbon is called alpha. So on this position, we get the substitution of any halogen. So it becomes RCH So when any halogen gets attached to the alpha position because of minus I effects, because of minus I, the electron shift towards this carbon and release of H plus becomes faster and hence it increases the acidic strength of the carboxylic acid. Question number 28. Reducing sugars. Simple question. Sugars or carbohydrates which reduce tolerance or Fehling solutions. Which reduces tolerance, Fehling's solution. Simple. Like all these monosaccharides we have. Glucose, fructose and all. Fibrous protein and globular protein. Fibrous proteins are water insoluble. So for fibrous, I will write water insoluble and they are long. Like we have keratin, or I can write collagen. For globular protein, these are spherical globules, spherical. They are water soluble and basically mostly all the enzymes or hormones These are the examples of globular protein. Nucleotide, nucleoside. So nucleotide, they have all three components, means base plus sugar plus phosphate group. Whereas nucleoside, they have only base and sugar. They do not have phosphate group. That is the difference. Okay, so this is the OR part of the previous question, 28 OR part, second part of 28. So reaction of glucose with the, okay, so this is with this we have oxime. So basically it forms glucose oxime, glucose oxime. So the formula for this one is, if I will write here CH, it is double bond and OH, then we have CHOH four times, and the last carbon is having CH2H. CH2H. So this is the product of A, first one. For this one, we have, okay, so this is acetic anhydride, so it forms pentaacetate. Pentaacetate. Basically, this reaction shows that 5 OH groups are present in the glucose structure. So for B, I will write the answer as it is again pentaacetate. So it reacts with all the OH groups. So I can write it as CHO, CO, CS3. So since all the carbons are having OH group, so I will write it directly as 5 times. This is the structure of pentaacetate. For third part, C, concentrated HNO3. So concentrated HNO3 converts glucose to saccharic acid. Saccharic acid means both the first and last carbon gets converted to COOH. So in this one we have CHOH 4 and again it becomes COOH. So this is the reaction for pentacid, means HNO3 and glucose. Okay, so this is the case based question part A. So part A is numerical based. So 29 part A. Let us solve this question. So this question is from osmosis. So I will write pi is equals to I CRT. And in this question, what we have to calculate is calculate the amount of CaCl2. For amount, we need number of moles of CaCl2. So ICRT can be written as pi is equals to I. C is what? Concentration. So number of mole by volume into RT. Now just rearrange this equation with respect to number of moles. So N becomes equals to pi into V into I RT. So pi is 0.7, then volume is 2.46 divided by 2.59 into R is 0.082. This is given in the question, 0.082, and temperature we can use at 300 Kelvin, or I should make it point and you can write 300.15 Kelvin. Okay, then basically when you calculate this, the value of N that we get is 0.027. This is the value of number of mole. So how do we calculate mass? Mass is calculated by N into molar mass. So N is 0.027 and molar mass is given here, this one 111. So we multiply this by 111. So mass of CaCl2 is going to be 3 point, means approximate value 3.02 gram. This is the correct answer for question number A, 29A. For B, when resins are kept in water, they get swollen. So this is basically because due to osmosis. So this process is called osmosis. So I will directly write osmosis here. Then B, or Second part, why osmotic pressure is more advantageous than other colligative property. So the thing is, this process or determination of osmotic pressure occurs at room temperature. That is the first thing, room temperature. And this method is suitable for the solutes having high molecular mass. High molecular mass. That means which have more than 5,000, means molar mass in thousands. So basically, like we have proteins or any other biomolecules. Protein, they generally have molar mass in thousands. So this method is suitable. Third thing, why it is important, because proteins, we have read about denaturation. So at high temperature, proteins get denatured. So it is again one of the most important aspect of osmotic pressure. Uh, since it is determined at lower temperature, so proteins are basically stable at lower temperature. Proteins are stable at low temperature. Okay. Third part, C. Which phenomena is responsible for desalination of C? So we all know this is called reverse osmosis, or in short, we call it as RO. Question number 30. Let us solve this one. So we have to compare, means complete the following equations. So in the first one, it is simple reduction. So the product that we get is CS3 CH2 NH2. Lithium aluminum hydride, this one, this reduces CO bond. Okay. Again, this is a reduction. So the NO2 gets converted to NH2. So NO2 will get converted to NH2, and this one is CS3. This is called 4-methyl aniline. 4-methyl 4-methyl aniline, or this is also called para-toluidine. Then why primary amines have high boiling points than tertiary? Due to ability to form H bond, hydrogen bonding, intermolecular, intermolecular. Okay, so you have to find primary, secondary, tertiary. So since this nitrogen is attached to this carbon and two carbons on this side, so this is going to be tertiary, and since it is having only one, so this is primary. For this part, C. So I will write the answer here for C, or. So out of butane, one amine and butane, one all, which is more soluble in water? Quite obvious, butane, one all. All means alcohol. So because of its ability to form hydrogen bond with water, alcohols are more soluble than these amines because of polarity and ability to form hydrogen bond. Next, how will you convert propanone to propene? So conversion, this can be done in many ways, but let us discuss any one of the possible ones. So I will write propanone means CS3, COCS3. So first what I can do, okay, let us reduce it with lithium aluminum hydride. So what we get is, when ketones are reduced, we get alcohols. Okay, so again, put H2SO4. H2SO4 is dehydrating agent, so we will get CS3, CH, double bond CS2. So basically we have propene. Even other methods are possible. Benzoic acid to benzaldehyde. Second one, benzoic acid, benzaldehyde. So we have benzoic acid and we have to convert it to benzaldehyde. So how can I do it? First, let us convert it to uh, chloro part. So we have best method is thionyl chloride. So when it converts to COCl, again, okay, same, we can carry out the Rosenman. So with Rosenmund, we have discussed this Rosenmund name reaction. So COCl means benzoyl chloride gets converted to benzaldehyde. This is Rosenmund. So here you can also mention that it is Rosenmund. Rosen. For third one, now we have to convert benzene to metanitroacetophenone. Benzene to metanitroacetophenone. Okay, so first let us carry out Fidelkraft reaction of benzene. So when benzene reacts with CS3 COCl, this is Fidelkraft acylation. So the reagent is AlCl3. So what we get is COCH3 acetophenone. And when this acetophenone reacts with HNO3 and traces of acid like H2SO4, so since COCH3 is a deactivating group, so it will direct incoming group to meta position. So I will write first, I will write COCH3. This is single bond. So it will direct to meta. So this is the product, meta nitroacetophenone. And even there are many other ways to convert this one. B. In this case, we have to arrange them in increasing order of their reactivity towards CN. Okay, so basically, sorry, we have to consider the steric factor. So here we have H. On this side we have CH3. Here we have tertiary group. So I think this one will have the highest reactivity, followed by this one, and then least is this one because of so much of hindrance on the carbonyl carbon. This is the carbonyl carbon, so there is a lot of hindrance. Okay, identify the compounds which would undergo aldol condensation. So for aldol condensation, the condition is at least one alpha hydrogen must be present. So this is formaldehyde, it doesn't undergo. Benzaldehyde doesn't undergo. CH3CHO, yes. Acetaldehyde undergoes aldol condensation. This one also, this is C double bond O. So with respect to this position is alpha. This is also alpha, and this is having two hydrogen each. So this one will also undergo aldol condensation. Next, or part. You have to give the chemical test to distinguish between following: acetophenone and benzophenone. Acetophenone means a benzene COCH3. COCH3 is distinguished by iodoform. Iodoform. Propanol and propanone, that means aldehyde and ketone. So simple one, either Tollens or Spellings. Any test. Pentane 2 on, pentane 3 on. Pentane 2 on, pentane 3 on. 1, 2, 3. Again, we can distinguish this by iodoform. Because when you write pentane 2 on, so pentane 2 on is written as CH3, CH2, CH2, CO, CH3. The moment it becomes CO, CH3, that means this is a test for, means this compound undergoes iodoform. Okay, which of the following acids are stronger and why? So which one is stronger? Obviously, this one is stronger, fluoroacetic acid, because of fluorine, it is having minus I. So again, we have just right now we have done HVZ. So because of HVZ, this halogen is placed, and halogen increases the acidic strength. Arrange the following compound in order of their boiling point. So boiling point, the first thing we have to arrange them in increasing order. That means first we have to write the that one which is having least. So I think this one is the least. So first we will write this one because this is normal alkane. Then this is acetone. So this should be the second one, because in this one we have only van der Waal, VDW, and in this one we have dipole. That is fine. In acetaldehyde, we also, this one is alcohol, so obviously this is going to be the last highest because of H bonding. and again this is dipole dipole, so this should be the third one. Okay, so why these CS3 CS3 or CS3 means ether, and these two are why this one is having higher, because in aldehydes we have stronger dipole dipole, whereas in ether there is a, because of symmetry, it is there is no polarity as such in comparison to the aldehyde. Okay, so now let us solve this question. Next question 32. Okay, so this is a little blur. Let us try to solve this one. So I will assume it to be 10 to the power, sorry, I will assume it to be 1.06. I'm assuming it to be 1.06 into 10 to the power minus 2 Simon centimeter inverse. So I will solve this question including taking this value. Okay, so let us do this one first. What we have to calculate is, we have to calculate molar conductivity and degree of dissociation. दो चीजें. So first let us calculate molar conductivity. We know that lambda m is equals to kappa into 1000 divided by concentration. So kappa is, I think kappa is given 1.06. So I will assume it to be 1.06 into 10 to the power minus 2 into 1000 divided by concentration is given, conductivity as 0.1 molar, so concentration I will take it as 0.1. So this will come out to be, when we solve this 1.06, this is 10 to the power minus 2, this is 10 to the power 3, so this will become directly 10. So I can write it as 10.6 into divided by 0.1. Okay, so basically I can directly write lambda m will be, remove these points, so it becomes 106, 106, and unit for lambda m is Simon centimeter square mole inverse. Writing unit is very important. So lambda m is going to be this one. Now we have to calculate degree of dissociation. So expression for degree of dissociation alpha is lambda m by lambda m infinity. So we just calculated lambda m, it is 106. Lambda m infinity can be calculated using, by adding these two values. So 50.1 plus 76.5. So when we add these two values, it comes out to be 175.12 120 126.6. So when we divide this, alpha will nearly come to 106, 0.837. So this should be the approximate value. Alpha is 0.837. Okay, next 32 part V. So again we have silver and zinc. So E naught cell is given 1.56. Predict the direction of the flow of current. A cell reaction in a galvanic cell, predict the direction of the flow of current. Okay, so this question is very simple. Since you will write, since this E cell is positive, since E naught of the cell is positive, which is 1.56. So since this EMF is positive, that means cell is working. Cell is working. That means reaction is spontaneous. So when cell is working, then only EMF is positive, and it means reaction is spontaneous. So reaction will be spontaneous only when zinc is getting oxidized and silver is getting reduced. Only then this reaction is going to happen, because silver is having a positive reduction potential and zinc is obviously we know minus 0.76 volt. So if this is the case, then only this cell is going to be working and positive. So if this is the setup, so I think flow. Okay, so question is flow of current. So you will write current current flows from Ag to this one, zinc. Why? Because Electrons means zinc is getting oxidized, so zinc will give electron. Electrons are moving from zinc to silver, so current will flow from silver to zinc. Okay. Differentiate between primary battery and secondary battery. Very basic difference. Primary batteries are of single use, like the one we have in our wrist watches. And in this, reaction is irreversible. Reaction is irreversible, that means reaction only proceeds in one direction. These are also called non-rechargeable. Secondary cells are multiple use, means we can use it again and again. Multiple use, and in this reaction is reversible, like we have mobile phone and lead batteries. So discharging, then charging, then discharging, then charging, and these are rechargeable. That is the basic difference between primary and secondary cell. Okay. So then or part of 32. So in this case, resistance of conductivity cell filled with 0.1 molar KCl solution is 100. Okay, so resistance is given for the first case. Using this data, if the resistance of the same cell when filled with 0.01 molar, this one, we have to calculate the conductivity. Okay, so basically using the first data, we have to calculate the second one. So I will write for the first one. This one is A part. For A, I will write cell constant. Cell constant is represented as G star. G star. So this is means conductivity first from first data, and R1. Conductivity K1 is given is this one 1 point. This is the kappa that is given 1.29. So I will write it as 1.29 into 10 to the power minus 2, and in first case resistance is 100, this one. So this is 100. So 10 to the power minus 2 and this 10 to the power plus 2, they cancel out each other. So the answer is 1.29. Cell constant is this one. Now we have to calculate conductivity. So conductivity of 0.01 molar KCl solution. This can be calculated by, since this is for second data, so K2 is equals to this we just calculated, cell constant G star and resistance of second data. So this is going to be 1.29. In second case, resistance is given 300. So I will write this 300. This will come out to be 0.005, no, 0.004 3. Unit is Simon centimeter inverse. So for this one, we have kappa for second experiment. Now we have to calculate calculate the conductivity and molar conductivity. So how can we calculate molar conductivity? Conductivity we have calculated. Molar conductivity is kappa into 1000 by C. So kappa is 0.000043. Then unit I will write at the end. This is 1000 divided by C is 0.01. When you solve this one, the answer is 430. Again, unit of this one is Simon centimeter inverse, square mole inverse. Units are very important. So 430 should be the answer. Now, second part, B. B first. So for B first, advantage of H2O2 fuel cell. So they have various advantages. This we can write because they are non-polluting, and high efficiency. High efficiency. And for this type of cell, H2O, water is the only byproduct. Okay, so and then for part 2, B part 2, why does the cell potential of mercury cell remain constant throughout the life? Very straightforward question. This is due to overall reaction does not involve any change of the ion, means concentration of ions remains same throughout their lifetime, during their lifetime. So basically, for these type of mercury cells, the ions which are present, their concentration never changes. The reason because reactants or products which are produced or exchanged are mostly they are solids, mostly solids, mostly solids. So they remain in the same concentration throughout their life. This question is very good. An organic compound A with molecular formula C2H6O reacts with this compound uh, to activators such as sodium to give compound B and hydrogen gas. Okay, so this seems to be any alcohol. So let us write the equation. So first one, C2H6O, C2H6O. So this should be ethyl alcohol. So I will write the equation CH3 CH2OH. So when this compound reacts with Na, it forms CH3 CH2O Na, sodium ethoxide. So I will think this should be A and this should be B. Okay. Second part is and hydrogen gas. So I will write H2 here. Hydrogen gas. A on treatment with iodine. A on treatment with iodine and sodium hydroxide. So this is iodoform reaction. Iodoform. CH3 CH2 OH. A on reaction with iodine and NaOH. So basically it forms iodoform CHI3, ये iodoform reaction, which to give compound C. So this iodoform CHI3 is C in presence of H2SO4. A on treatment with iodine gives compound C, and in presence of H2SO4 at 430. Okay, so 413, this temperature, this is very important. 413, it undergoes intramolecular dehydration to result ethers. So I will write this reaction separately. So when CH3 CH2OH, it reacts with H2SO4 at 413. So it forms ether CH3 CH2O CH2 CH3. But for additional knowledge, when this reaction occurs at 443 Kelvin, so this reaction undergoes intermolecular dehydration. So it forms alcohol, it forms alkene, but this is not required. So in this case, ether is formed and match the molecular formula. It gives C4H10O. So 3 plus 2, 5, C4H10O. So this should be D, diethyl ether. Okay, and then when this D on reaction with Hi gives E. So when this D means diethyl ether, when this reacts with Hi, so it forms E. So basically it is a reducing agent, so it will reduce it to CH3 CH2I. So I think this should be the E. A B C D E. So A is alcohol, ethyl alcohol, B is sodium ethoxide, C is iodoform, D is diethyl ether, and E is iodoethane. Question number 33, part or. Okay. So write the reagent which are used for the conversion. Phenol to 2,4,6 tribromo. This one. So for this one, phenol converts to 246. So basically, this is a reaction of Br to water. Br to water. Bromine water. So bromine water, it forms 246, 246 और यहाँ पे लग जाएगा OH. This is Br, this is Br, this is Br. 246 tribromo. This one. Propene to propane 1-ol. So for second, propene to propane. Okay, so you just have to write the reagent. So I will write the reagent. Propene to propane 1-ol. Propene is this one. CH3, CH, double bond CH2. Propene. So carry out the anti-Markovnikov in presence of H2O2. So anti-Markovnikov results in not OH. This is Br. 1-bromopropane. And when this 1-bromopropane undergoes aqueous KOH, aqueous causes substitution. So this will be CH3, CH2, CH2OH. So we converted propene to propane 1-ol. So what are the reagents required? You can write HBr and H2O2 means anti-Markovnikov addition followed by nucleophilic substitution by aqueous KOH. Butane 2-on to butane 2-ol. Third one. Butane 2-on to butane on to all. So this is a simple means ketone to alcohol. So this I will directly write. A reagent for this one is lithium aluminum hydride, or even we can use sodium borohydride, or even any other reducing agent. Simple one. Okay, so this last question 33 part B. This one. Explain the mechanism of acid catalyzed hydration of alkene to form corresponding alcohol. So basically we have to write the mechanism. So let us write the mechanism. Acid catalyzed hydration of alkene. So I will write alkene. Then acid catalyzed. So I should use sulfuric acid. Sulfuric acid is H2SO4. This is the formula for H2SO4. So since this will capture this H plus and this bond will shift to this side. So it will be CH2 and then this hydrogen gets added to this side and then it will be CH2 plus carbocation. Again, because of the presence of water, so this positive charge will get protonated and we get CH3, CH2, O, this one O, and since O is having H2, so this H this side and this H this side, this oxygen will acquire positive charge. In the next step, this is HSO4 minus. So this HSO4 minus will come, which was eliminated here, HSO4 minus. So this HSO4 minus again it will come and this minus charge it will abstract one hydrogen from here and then this bond will shift to this side and we get the product CH3 CH2 OH. So this is the acid catalyzed conversion of alkene to alcohol. In this way we can write the mechanism. Thank you.